We just explored one common geometric object, a line. Let's see if we can talk about another one. And the geometric object that I want to talk about is an object where it is the set of all points that are equidistant from a single fixed point. So in other words, if you draw a dot somewhere on the coordinate plane, you can look at all the points that are equidistant from it. So in meaning that this would be D, this would be D, this would be D, all of these distances from the fixed point would be the same. Okay, and you can probably say, yes, Professor Bright, this is a circle. Yes, and these are actually what we call radii. Okay, how do we represent this algebraically though? Like geometrically, like sure, we get it. Algebraically, let's look at the distance formula. Okay, so the distance formula, right, we know is x2 minus x1 squared plus y2 minus y1 all squared underneath a square root. Okay. And what we're going to do is we have to fix a single point. So I'm going to say that x2, y2, just for simplicity, that is going to be our fixed point. Okay. And so when we fix it, we just use, oh, I'm sorry, actually, my bad, x1, y1, that is our fixed point. Okay. So that's going to be our fixed point. And then for that purpose, I'm going to call this HK. Okay. And then x2, y2 is any point that is equidistant. So it can be variable. So I'm just going to use a general xy. Okay. So if I rearrange this, d is equal to square root x minus h squared plus y minus k squared. Okay. And then now square roots, I mean, yeah, you can leave it like this. It's nicer to get rid of it. So if you square both sides, you end up with d squared is equal to x minus h quantity squared plus y minus k quantity squared. And then at this point, typically we just let d equal r for radius. And then if we swap sides of the equation, we just get x minus h quantity squared plus y minus k quantity squared is equal to r squared. And that is precisely the equation of a circle, where we have its center, that fixed point. Okay, so center is the fixed point at hk, and we have a radius r, or the distance from that center to any point on the circle is r. Okay, so one quick example is this one. So we want to identify the center and the radius of the circle with this equation. Okay, plot the circle in a graph. Okay, so I think it's fair for us to say, okay, if we just compare this to the given equation, so x minus h squared plus y minus k squared is equal to r squared. Okay, I can see that 4 is 2 squared, so I can say that the radius is 2, and now I need to know h and k for the center. Just by comparison, I can see that k is 4, okay? And then h, I have the signs that don't match. What I can do is represent this x plus 3 as x minus a negative 3, okay? So whenever we see plus, remember that we can write that as minus minus, okay? So there we go. We can have our center at negative 3 comma 4. Okay, so then we just have to do a little sketch. Negative 3, 1, 2, 3, 4 units up, 1, 2, 3, 4. There's our center. And then the radius of 2 means that it extends 2 units in every direction from the center. Okay, so I do kind of compass points. So go up 2, go down 2, and then to the right 2, to the left 2, and then just do my best to kind of sketch a circle. Okay, that's the rough idea. Again, my picture isn't perfect because my scale isn't perfect. Okay, there we go. All right, next equation. This one is fun. Okay, we have to identify the center and the radius of this circle. Okay, doesn't look like the h and k and r squared. So what do? It says hint complete the square. Okay, we might need to look up a YouTube video if we don't remember how to complete the square. The idea I always suggest is get all the variables on one side, all the non-variables on the other. So I'm going to subtract 2x, add x squared to both sides, and then I'll minus 6. Okay, and after all this is done on the right side, I'll have minus 6. On the left side, I have y squared plus 6y, and then plus x squared plus x squared minus 2x. Okay, so there is what I have so far. Now, completing the square, the idea is you want to go from this form, and maybe I'll even take one more line and I'll do the x's first. X squared plus, minus 2x, and then plus y squared plus 6y equals minus 6. The idea is that you want to get this to factor into something like x plus or minus something squared plus y plus or minus something squared is equal to a number, right? That's the general form for the equation of a circle, okay? So now, to find that number that you need to add, you take half of the linear coefficient, -1 in this case, square it, 1, and add it to both sides. Okay? Completing the square again, take half of the linear term, so half of 6 is 3, square it, 9, and add it to both sides. Okay? When I do that, then this factors as, since it's x squared minus 2x plus 1, that will factor as x minus 1 all squared. And then the y squared plus 6y plus 9, that will factor as y plus 3 quantity squared. And then I get I have to do the arithmetic here. So 10 minus 6 is 4. And so then here I can say that the center, HK, is at 1 comma minus 3, again, minus and -3, right? Okay. And then I can say that the radius, this 4 is really 2 squared, so r is 2. Okay. So completing the square, if that's a little shaky to you, look up some videos on YouTube or Khan Academy or something and get some practice with that. It is a kind of a fun algebraic strategy, but it does take a little bit of work. And with that, we've completed our study of circles. So again, the general equation is x squared, or x minus h quantity squared plus y minus k quantity squared equals r squared. And then we have a center hk and radius r. Okay, so we'll get some more practice with this coming soon.